Hi, it's me again, Mr. Baumann, here to talk to you a little bit about ice and glaciers, your third topic, if you are doing this topic from our research project. What I'm going to do is look at each of these four sources, just kind of give you a breakdown. I'm going to go in order. I've already got them loaded up. We're just going to click through and go in order. I'm going to talk about what I see. I'm going to give you some information, help you answer your questions. Here we go. First site, NASA's climate science page is a really good place for any information related to climate change. We've got a big list of all these things. Really, like, lots of really good stuff. If you want to explore more about climate change, you can look into all the different topics. We've got CO2, temperature, you've got your Arctic sea ice, ice sheets, sea level, evidence, causes, effects, consensus, questions. We're currently on the vital signs page. There's lots of stuff you can see here, but what you need to focus on for your project right now is this first tab here, Arctic sea ice, and the second tab, ice sheets. So this is our first source, and then our second source, if you were to click here, it would take you here. That's the two things we're going to focus on the most right now. Okay, so the rest of it's just there in case you want to look at it, but right now I want to show you kind of what's going on here. So Arctic sea ice minimum, that's the minimum amount of ice available on top of the water in the Arctic. Okay, so in September is when we get our Arctic sea ice minimum, and these measurements are taken in September. Okay, so basically they measure them. They're using satellites to do this. So if you're looking for how do we get this data, well, we use satellites to use images, and measurements from those satellites and those images help us to figure out how much ice there is. Okay, and then we compare it to previous year's ice to calculate the Arctic sea ice minimum. Okay, so that's how we got this graph. That's the how. So it's in millions of square kilometers. So square kilometers would be like, you know, a different way to measure distance, right? So that's the area that the ice is taking up. And you can see that since the early 1980s, we've had some ups and some downs, but generally the trend is following that it's going down. Okay, we did have a spike recently that we're still coming down from, so we'll kind of see where we go from there. But generally, if you were to like smooth this out and draw a line, it would go down to the right? So you can see that our ice is decreasing quite a bit. They've even said here the rate of change is 12.85% every decade. So every 10 years, we lose about almost 13% of the ice that was covering water, Arctic sea ice. Okay, so that's kind of what you can see. The graph shows the average monthly Arctic sea ice extent each September since 1979. Okay, this is pulled from satellite observations. And then down below, there's an animated video here. That's what we're going to look at in a second. And that shows the annual Arctic sea ice minimum. Same information, really. And you can kind of see the amount of ice. So these are basically pictures of that sea ice. Okay, so this is the data. If you're looking at the graph, you like looking at graphs, right? You can see it's going down. And then you can actually, like, you can zoom in if you want to see, but there's not a lot really different about it. I mean, it shows you months. These are January, the beginning of each year, but the measurements are in September, so it doesn't really matter. Okay, so here we go. Ready? Let's look at it. From 1979, here's the actual size of the ice sheet. You can see it's changing quite a bit, and some years are lower than others, or sometimes it's different than others, right? And you can kind of see what's going on. By the way, the Arctic, that's like the North Pole, so you can see Alaska and Russia and stuff up here, right? So, wow, did you see that one? Really, really small. And it's just significantly smaller now than even it was back in 1979, right? So less ice as you get to now. And you can see every year going by up here in the top. So if I drag it back, you'll see 2002, 2006, right? Okay, so that's how you can use that to help you out. I think that this one's pretty straightforward. There's less sea ice. Okay, let's go on. Ice sheets. Ice sheets are ice that take up large spaces. Oftentimes they're on land. And how we're measuring them, the data from this ice is measured by NASA's GRACE satellite, which is a satellite series that is measuring depth and ice amounts and things like that. It measures how much water there is and things like that as well. It measures a lot of things. GRACE is a pretty cool satellite mission if you want to look into it, but really you don't have to. Just nerd stuff. Okay, so this data is showing that land ice sheets in both Antarctica's up here, that's the South Pole basically, and Greenland, right, that's a big glacier in the Northern Hemisphere, have been losing mass since 2002. The GRACE mission concluded its operations in 2017. So GRACE stopped happening in 2017, and then there was a GRACE follow-on, which began collecting data in 2018. So that's why there's a space where we didn't have data, because we didn't have anything up there collecting it. So they actually sent another mission up to go and do that. Okay, so there's a little bit of a lag time. So yeah, that's how you can look at those. So let's take a look at what these are showing. So this is showing from 2002, and it's in gigatons, I believe, of Antarctic ice. So that's just basically how heavy the ice is, or how much ice there is by weight. So you can see that zero's at the top of the graph, which really shows that we're we're losing quite a bit of our ice. So you can see we're going down by about 146 gigatons per year in Antarctica, and even more than that in Greenland, right? And it might be because Greenland is actually closer to like where there's a lot of people, and the North Pole is actually experiencing a lot more of the temperature change globally. So if you get connected with the temperature change person, or you go and look at the temperature data here for global temperature, you'll see, if you look at the reconstruction, that's actually warmest in the high North Pole area. In terms of, not warmest, but has the most drastic increase. Sorry, not warmest, obviously it's very cold there. But you can see that the ice amount is just going down in gigatons. I mean, these are good graphs to just take a quick screenshot of, right? So like just, that's not a screenshot. Sorry. Take a quick screenshot of, right? And throw those in your presentation. Make sure you include a proper citation and tell us what they mean, right? That'd be a good thing for you to be able to do. So now you've got a little bit of the how did we get this data and a little bit of the what's happening and why do we care, right? Because obviously if the ice sheets are going down, something's causing them to do that, right? What's making that melt happen? And here we go, third source. Warming ocean causing most Antarctic ice shelf mass loss. So as the ocean gets warmer, we're losing our ice that's touching that water because it's melting, right? Ice that's touching water can float around for a long time if that water's quite cold. But if the water gets warmer, more ice melts, we lose more ice, okay? So this is actually a really complex article from NASA, lots of jargon and whatnot, but I'm here to break it down for you. Don't worry, I'm here to help. So what we were just talking about, when ice melts because it's on top of water, that's called basal melt. Okay, so I'm going to highlight that. Scientists have studied the rates of basal melt, or the melting of ice shelves from underneath of individual ice shelves, which are the floating extensions of glaciers that empty into the ocean. So basically, here's a picture of Antarctica, right? A lot of Antarctica is covered in glaciers, and those glaciers, as they get built up, they push away towards the water. That's where the extra ice gets kind of pushed onto. And these spaces that are colored, this is ice that was touching water, okay? And we're going to look at this in a second, but let's get back to this over here. So that ice gets pushed off the land, and it sits on top of the water, and that's where a lot of our fresh water is in these ice sheets, these glaciers and things, right? But as the ice begins floating, some of it's going to begin melting. Now, some of these ice sheets are actually going to grow because the water is cold enough and the ice is cold enough to actually melt the water that's touching it. Or sorry, opposite, freeze the water that's touching it. But what we mostly are seeing is there's a lot of melt happening, and that's what this is telling you all about. So if you read this article, it tells you all about that. Again, there's lots of fancy schmancy words and things like that, but the idea here is that we've got two different ways that ice can be lost, and it's by melting from water touching it or from breaking off of the glaciers, which is called calving. And if you want to like see some cool things, just go to YouTube and put in like glacial calving or ice calving. There's some really cool videos of like just big hunks of ice breaking off. It's pretty neat. But we're here to talk about the basal melt. So let's look at this graph or this picture here. This is really, it looks really complicated. There's all these pie charts and these colors and stuff. What we're looking at here is if you're at 0 in these areas that are touching water, okay, that's around the outside in these little bays and little crevices and things that are near the land, right? That's where most of the sea ice is hanging out. If you're in the red here, you're not melting very much. In fact, your melt rate has actually gone down lately. But if you're in the blue, then you've got lots of melting, so high melt rate. So there's more ice melting in those blue areas. So you can see some of these blue areas are becoming affected. So if I said red is bad, then it would look a lot worse, but blue is bad in this case. And then the pie charts for each of these locations are actually measurements taken by satellite showing how much of that is basal melt. So down here at the bottom, it shows you black is melt, and then the kind of like dashed lines, that's from calving, so ice breaking off. So you can see down here in like West Ross, all of the ice that came off of this ice sheet calved off, which means it cracked off and broke into the sea and became an iceberg and floated around searching for ships to sink. Okay, but in some of these places like George VI here, it was mostly melted from underneath by the water. Okay, so you can see there's a pretty big increase in melt, and the size of the pie chart shows how much ice was lost. So a lot of ice was lost in these bigger charts and then not very much in these smaller charts. Okay, but that's what that graph is showing if you want to use it or you want to explain it or you just wanted to know that. So now you know. Reading this kind of tells you more about it, a little bit about how ice gets there and how ice melts and how these processes work, right? So here you can see changes in basal melting are helping to change the properties of Antarctic bottom water. So that has to do with ocean circulation. It's one of the components of the ocean circulation. So hopefully you learned a little bit about ocean circulation when you learned about currents last year. Talked about air and water currents. So like warm goes up and cold goes down, and there's this temperature cycling that drives things, right? It's based on density because warmer things end up being less dense and colder things more dense, right? Well, if you get warmer water coming up in these cold places and you melt away some of that cold ice, it changes the temperature, it changes the density, it changes the makeup of the water. It changes the way the water flows, which can then adjust weather around the world. Okay, so that's kind of what this is talking to you about. So here you can see ice shelf melt doesn't necessarily mean an ice shelf is decaying. It can be compensated by the ice flow from the continent. But in a number of places around Antarctica, ice shelves are melting too fast, and as a consequence, the glaciers are changing as well. So as the ice shelves melt, the ice shelves, the things that are sitting on the edge, they kind of hold back the glacier. As they melt away, more glacial ice is going to push itself to the outside, thinning out the glacier. As the glacier gets pulled thin, it's like if you have a stick of Laffy Taffy and you're just pulling it, it's going to get thinner and thinner and thinner. It'll break, we're going to lose a lot of that ice, and that's not good, right? Because that would raise your global sea level quite a bit, because it's a lot of water. And raising your global sea level would make it really hard for us to store old people in Florida and things like that, so keep that in mind. Okay, that was source number 3. Here's source number 4. This is just a really cool way to kind of look at this ice. So if you want to look at glaciers, you can click on the glacier one. You can go and look around. So you guys are from the United States, right? So go look at the Rocky Mountain glaciers. Here you can see literally on land. Here's a glacier in the Rocky Mountains, 1898. Here's what it looked like then. That's what it looks like in 2003. Okay, so like this is pretty massive. This is not so much, right? We can go back to the map. We can look in the Andes. This one's pretty insane. Here you've got a glacier in the Andes in 1978, and here it is in 2004. It's mostly a lake now. Okay, so that's kind of what we're looking at here. Is you can actually see we've lost tons and tons, even billions of tons of ice since 1994. It says. So let's find another cold place. How about the Himalayas, right? So here is a picture from 1956. Sorry, it's torn in half. And you can kind of see where the glacier is and the edges. There's a little bit of water down there, right? But take a look at it today. Or, well, 2007, right? You can kind of click through. There's more of them to see, right? So there's lots of these Himalayan pictures here. And you can do the same thing, click through and look at them in South America. I mean, these places are beautiful, but that's not why we're here. We're here to see that, wow, look at all that water relative to all that snow and ice that was there before. Okay? So then you can even look at the ice sheets. Like you can look at Greenland. And then here they show you even real-time measurements and things like that in the video. So you can kind of see just how massive this is. So they included measurements for you so you can see 3.6 miles by 3 miles. It's a massive sheet of ice, okay? And then, you know, as time goes by, here's a time lapse even of it growing, of it shrinking, and you can see there's ice coming off that's calving, or you can see that it's melting away as well. So you can kind of see the flow of the ice sheets. Ice sheets are flowing, and wow, that must be the cold season. That's pretty cool, actually. I've never seen this before. It's really fantastic. Look at that. Now we're getting back to the warm season and we're losing our ice again. Okay, so you kind of see how the glacier's moving, which is pretty neat, I think. And you can do that all over the world. If you want to go to Antarctica, you can go there and you can be like, okay, tell me about the major ice shelves. Show me the flow of the ice. Okay, so it's showing you the direction of flow. All right, these are the areas where it's flowing out from, and these areas where it's flowing into. It's pretty cool. And then here's the trend, which you already saw that, so you don't need to see that again. Okay, here's another ice trend. You can even see that changing as time goes by. So there's lots of really cool things here on this NASA site you can use just as visuals, because I know a lot of your classmates are going to be visual learners, or maybe that helps you to explain your point. So feel free to use those. Thanks for watching. Good luck with your project.